Bhargav J. Shah joined online discount retailer Overstock.com in 2013. In his role as Senior Vice President of Technology, Shah is responsible for providing vision and leadership for developing and implementing information technology initiatives within the organization, as well as influencing business strategy through the innovative use of technology. Prior to joining Overstock.com, Shah worked for KPMG LLP beginning in 2009 as a director in its IT advisory group. At KPMG LLP, he helped various mid-market and Fortune 500 clients with defining and implementing their enterprise IT strategy. Previous to KPMG LLP, Shah worked for Bearing Point, a management and technology consulting firm, for 10 years, becoming a senior manager. Shah holds a chemical engineering degree from KES Engineering College in Mumbai, India, and a master's of business administration from Bentley University in Waltham, Massachusetts. Could you join me in welcoming Bhargav Shah?
Hello, everyone. Good afternoon. First of all, I'd like to start by saying thank you. Thank you for having me here. I'll try to not bore you all after that delicious meal that you all had. I'm sure there are some yawns I'm seeing around. And we are going to talk about a very interesting topic, electricity. Everyone like that topic, right? We are going to get into how you wire and how electricity works and all. It's a tech summit. Should be talking about electricity. But anyways, the topic that we are going to talk about today is emerging technologies and impact on broadband. And by the end of this presentation, you will see why I was very confused with this title, because I was wondering if I should call it Emerging Technologies and Impact on Broadband or Broadband and Impact on Emerging Technologies. And you'll see why we talk about that. So, oh, by the way, before I start on this presentation, I should say the previous presentation by Matt on cybersecurity was great. There are two things, though, which were very interesting. One, I totally agree with. Flying drones on Windows 95? I mean, come on, really? So I totally agree with that. But I do have to disagree with one point. He said something about programmers making mistakes. I was a programmer. We don't make mistakes. Are you kidding me? Right? Any programmers in the crowd, by the way? Do you make mistakes? Never. Exactly. What are you talking about? I'm just kidding. I mean, I'm sure we all do. But anyways, what we are going to talk about today is, like I mentioned, history of electricity. Interesting because it does have some modern parallels in some modern worlds, and we'll talk about some of those. We'll talk about parallels in computing, importance of broadband and emerging technologies, and impact of emerging technologies on modern world, things and technologies that we all use today. Okay? Let's see. Oh, actually, before I go to that, I'd like to start with a quick poll. How many of you know who invented electricity? No one? Really? There you go. That was a trick question. No one invented electricity. It was discovered. Okay, who discovered electricity then? No one again? Okay, how many of you think Benjamin Franklin? Raise your hand. Few. Okay, back. How many of you think Thomas Edison? No one? I thought Thomas Edison will get more hands than Benjamin Franklin. Okay. Well, the reality is I think you guys are all pretty smart. I tried to trick you, but it's neither again. The answer is that it was discovered first as static electricity by, I can't pronounce that name. It was in 1660 by, I tried, Otto von whatever. Must be a German. Any Germans in the crowd? Okay, then it's okay. But anyways, the point is that it was discovered as static electricity, and now Thomas Edison and Benjamin Franklin both did have significant parts to play in the evolution of electricity as we know it. It was Thomas Edison who actually built the first power plant with direct current, DC as we used to call it, which could actually travel over wires. So it was no longer just a static electricity, it was a direct current which would then help power various devices. or various, various machinery, I should say, in those days. We didn't have devices. Wasn't small. We always had like giant machinery then. But one of the unsung heroes in this whole electrical history was a guy named William Stanley, or Bill Stanley, Jr. What was his contribution to this whole electric world? He was the guy who actually figured out how could electricity be transmitted over long distances, over wires, right? If you just had electricity being generated, in old days it used to be generated by turbines, but if it could not travel over wires, then each and every company or individual or residences or commercial buildings who needed power would probably have to kind of have their own turbines. And quite frankly, that is how it was. If you look at the extreme left of the graph or of the slide, turbines were the way electricity was manufactured hundreds of years back, right? Or well, I shouldn't say hundreds, about 100 years back. And each major corporation, which was manufacturing or doing whatever, and needed power, they needed their own turbines. And obviously, over time, people figured out how to make it a little more efficient and so on and so forth. But you would see that was one of the main reasons, by the way, I figured it out after I learned the history. I always used to, whenever I used to take a long flight cross country, I always used to see those factories, throwing smokes up their chimney, almost always located along the river bank. People observe that? Yeah. That the primary reason for that is in olden days, those were really old factories, by the way, and in those olden days, they would need to be near a water supply so that they could power the turbines. Usually those were water-powered turbines. And they churned this turbine, got the electricity, got it into the machinery and so on and so forth. What this fellow, Bill Stanley, did is what you see in the middle, the overhead power line. Not as sophisticated as we see it today, but he figured out a way that we could actually generate mass-produced electricity, right? And then just transmit it. So now instead of each of those factories needing their own turbines, you could actually have a central location where you can invest in the latest technology, you can make it more and more efficient to produce electricity. However, that idea initially failed. You know why? Because of two reasons. One was that even though he figured out that it could travel long distances and you could manufacture electricity centrally, and then you can transmit it to whoever needed it, the problem was cost of transportation, right? So who was going to bear the cost for building that infrastructure, for building those large overhead power lines that could then carry that current over that infrastructure to the destination where it needed to be used? So several of those companies that were using turbines, they said, okay, great, nice to see that someone else can mass produce this cheaper, but then when you took the whole equation of producing the electricity but then also transmitting it to where they needed it, the cost equation did not add up. It did not work for them. So what we see today, the plug-and-play technology, it had its roots, if you will, into building those efficient overhead power lines. One of the other things would also be interesting is also the speed. Today it's almost incomprehensible, but even back in the days, it would not work very well if a manufacturer had to turn on a switch and then wait 30 minutes until the power got there from wherever the central location where the power was being produced, right? That would not work. So even the speed of transport, how quickly it carries. Today we don't even think about, right? It's instantaneous. You just plug in and you got power. But that overhead power lines, and I'll tell you why it is that important and the point I'm trying to get to in terms of it's parallel in the modern world. But those overhead power lines kind of acted as a catalyst, if you will, to kind of move from technology of each individual kind of manufacturing their own power to having it manufactured centrally, more efficiently, and then it being transmitted, again, very efficiently over these power lines. So until we figured out, which again started with Bill Stanley, but then obviously over time you had people kind of, constantly innovating and finding out better and cheaper ways to transport electricity. That piece of the puzzle was almost always missed. Whenever people talked about the history of electricity, we hear about a lot of innovation and things about how electricity was produced, direct current to what we call today as alternating current, right? Everyone heard of AC, DC, right? But we don't hear a lot about the innovation of the infrastructure that then enabled that electricity to be mass produced, and it took us several years before we could get into this plug and play, where all everyone had to do is run a wire from one of those overhead lines into your facility, have plugs all over the place, and then you plug anything in and you got power, right? So great. Now, why are we talking about electricity? Because there is a very interesting parallel in the modern world today. How many people in this room have data centers? Pretty much almost everyone. Okay, so I'm going to talk about two technological innovations here, which are very important. So again, starting from the left today, I'm sure people here have heard of like mainframes, right? Mainframe technologies started in 70s. People computing. So instead of humans trying to figure out very complicated algorithms and equations, we had machines and mainframes trying to do that. Obviously, that meant that you needed large compute processing power, right? Those were that was the very origins of mainframes, if you will. And during that time, over time, again, there was a lot of innovation. Those mainframes became smaller. You have servers now, and then today you have like racks where you just have like really very thin servers, if you will. Then came some innovations such as client-server technology. What was client-server technology? Is that instead of computing everything on the mainframe and having the front end as a dumb terminal, the client-server technology allowed you to kind of access that computing power that you had on the server to be accessed through your desktop, through the computer that you use on your in your offices or in your home, right? And that client-server technology is also very important innovation, because what that did is that you did not always have to put everything on the server. You could put certain things on your desktop for speed, right? We remember in the previous slides that speed was very important. So it was very important for the speed, but then also very important to kind of decouple and have certain technologies reside on the server, certain technologies reside on a desktop. Now, so data centers, innovations there, from mainframes to modern computers and modern servers. The other parallel there was that the adoption of that compute power also needed internet evolution. How many of you have used the 56K dial-up modem? Remember you had to dial in? By the way, everyone who showed their hand are dating themselves, you know that, right? Including me, by the way. But, so from a 56K dial-up modem, I'm going to ask a question here again. Say, how many of you are very likely to actually update your Facebook or Twitter accounts if you were on a dial-up modem? Anyone? Not really, right? So speed is important, right? Again, it goes back to the speed. But one of the other things I'm going to also talk about here is now drawing the parallel with electricity. This whole compute power was not very widely available. It was only during, if you think about in the mainframe days, it was only in the office that people had access to such large compute powers, right? It wasn't omnipresent. It wasn't widely available. However, internet had a big role to play in that, because as internet evolved from being on a 56 kilobytes per second speed and having that annoying sound, before you try to connect, right? From there, the internet has come a very long way. Can anyone answer this question? Don't read the slide. How long it would take for, let's say, a 30-minute video to download on a 56 kbps modem? Pretty long. How many of you are willing to wait 4 hours to watch a 20-minute video? No one. I figured. So it was very important that as internet evolution with broadband, moving from those dial-ups to more broadband, from DSL to today. Many of, including in Utah State, we have several of those service providers, ISPs, internet service providers, providing up to 10, 20 megabytes per second. Spectrum shift, we are talking about kilobytes not too long ago, 15 years back maybe, 20 years back, to today, where we are talking about megabytes per second. And by the way, I think it was just a couple of months back in news that in Japan, Sony is backing an ISP that is laying down neurofibers. Now, neurofibers is a new term, or next level of evolution from what we today know as optical fibers, right? Which can provide 2 gigabytes per second type of speed. Huge innovation. Think about from 56 kilobytes per second to 2 gigabytes per second. You are talking about literally 1,000% up innovation in terms of going from the in terms of amount of speed. So, anyways, what that did is what it allowed a lot of capacity, a lot of data and compute power to be accessible more broadly. How does this? Why is this a parallel to electricity? If you think of those turbines, they equate to what you may call today as your data centers, right? In the past, you even had those data centers in a closet. And then obviously, as compute power and needs increased, people started building large data centers. Today, you must have heard of infrastructure as a service. How many of you know of Amazon Web Services? Pretty much all of you, see? So Amazon Web Services, Rackspace, there are a bunch of things out there. They're called infrastructure as a service, and they're all broadly coupled into what you would call as cloud computing. Now, there is a very interesting story of why it is called cloud computing, which I'll mention in a few minutes, but let me finish this thought about. So as this compute powers, now Amazon, Rackspace, all of these infrastructure as service providers, can they build a larger data center which is a lot more efficient? Just like in electricity, you could produce electricity centrally, much more efficiently, putting in investment in a lot of innovation? Absolutely. However, do you think if we were still stuck in the age of that 56 kbps, kilobytes per second age, would people be using those cloud services? Think about it, right? Almost impossible. If you're talking about taking almost 4 hours to download a 30-minute video, I mean, the amount of compute power that companies need these days, they would probably, you would have to do something and wait 24 hours before you get some results back. That would probably not be very good, and people won't be using it. So internet and broadband is playing a big role in adoption of what you would call as cloud computing. So that's the parallel of saying, once you have figured out the speed and the cost of transportation. So if internet had not evolved to where it has evolved today, it would have been difficult to even comprehend something like cloud computing. Now, the story behind cloud computing is that why is it called cloud computing? Any network engineers in the room? There you go. You know what cloud represents in a network diagram? Okay. That was a good answer. Back in the days, whenever you drew a network diagram, you would draw routers and switches. By the way, for my non-technical friends here, routers and switches are ways to pass data and route data over cable lines, if you will. And then you would always kind of, in the end of the diagram, you showed that LAN diagram, which is an acronym for local access networks, which is how you would get data throughout your company, just like that plug and play. Instead of plugging in the socket, you plug into your Cat5 cables or whatever, the network sockets. After that, it actually, after it passes your building, the last mile, it actually used to have a drop into what you call as a backbone. Backbone meaning there were large cables, just like the overhead power lines. There were large cables underneath the ground, which would carry lots and lots of data. And those were known as backbones. So those were almost always represented in a network diagram as a cloud, meaning that network engineers didn't care about it. And those were typically managed by some of the large providers like AT&T, Verizon. In the past, it also used to be MCI. I don't know if they're around anymore. But anyway, so as those large providers kind of had those cloud. Cloud computing means computing over internet, meaning you're able to access raw compute power or, quite frankly, applications such as Salesforce, such as Workday, such as many others that you can access over internet. And then it also applies in our personal lives, right? When you're using your smartphones, almost everyone has smartphones, I assume, these days, right? Your smartphones, the evolution from having a regular handheld device to smartphones and accessing data over smartphones is also supported by, if you thought of broadband in the wide term, it was not just the wired connection, but even the wireless spectrums, right? We started with wireless connections, and you had 2G, 3G, 4G. This day you call LTE, right? So all of those evolutions on the wireless network side allowed handheld devices to kind of access data and access different types of applications on your smartphones. And hence cloud computing is both about being able to access various applications and compute powers, if you will, over both wireless and wired internet. Okay? So that was the whole history behind cloud computing. So anyways, the long story short here is that without the evolution of internet and broadband, we wouldn't have cloud computing. However, it's not limited to that. How many people today are using voice over IP? And I'll keep the acronym out there. Vonage, anyone using Vonage or Cisco devices in their companies? Pretty much a large portion here, right? So what is this? In the past, when you used to have those modem lines, you had to connect your phone line into the computer. You could either call or use internet, right? Then came along DSL, where you could still use the phone, and you had a better, slightly faster internet service. But as the broadband internet services improved, and improved from what I mentioned as from kilobytes per second to megabytes per second, you saw convergence in voice and data. People started using on the commercial side. We started using, now you would say, several of you, if you go back to work, you may see this, is you actually have a network cable instead of a telephone line going into your phone. Pretty interesting, huh? What that means is now that the network and broadband internet connections are so big these days that you can actually have voice and data both ride on the network at the same time. And that's what voice and data convergence is. And so it's a total, again, spectrum shift from having phone lines to internet, and now using internet to making phone calls and communicating, okay? So voice and data convergence, so from dial-ups to voice over IP, which basically means voice over internet protocol. Voice over IP is an acronym for that. And of course, on the wireless side, we mentioned about 3G, 4G, LTE. And on the residential side, several of us may be using Magic Jack or Vonage or a bunch of other devices that actually allow you to make phone calls, long distance phone calls, even international phone calls at a fairly cheap rate, because it's going through the same internet lines as the data goes over. Okay? We talked about cloud computing. Another interesting area, social media, right? One would say, what has internet to do with social media? But I just asked a question a few minutes back where I asked that, would you really update your Facebook status if it took you like 10 minutes after you pressed a status update, right? So if the broadband internet technologies had not evolved to where it had evolved, or where it has evolved today, then it would have been extremely difficult to imagine a world where people were using social media a lot more than, quite frankly, than face-to-face networking, right? I mean, some of the latest studies that have come out there are talking about how the newer generation is preferring to do a lot more of social networking through internet rather than going out and meeting people, right? So pretty spectrum shift there, social media and networking. Now I talk about the next big term, buzzword here, big data. How many of you have heard of big data? Everyone, right? Now, one could argue that social media has given rise to big data. So first, let me start by defining what big data is. Now, obviously, as the name suggests, if you said big data, the first thing that comes to your mind is most of the people say, oh, big data means it must be lots of data. Yes, it is, but that's only half of the answer. Big data is defined by 3 V's, okay? volume, meaning indeed it is lots of data, but it's also defined by the second V, which is variety. In the past, the technologies were not there. Whenever you kind of visited your internet, the technologies were not there to kind of track every, if you visit a website, right? Then it was very difficult to know your purchasing patterns, your buying patterns, if you're buying at an online store. So that data, however, was known as structured data. So yes, that volume has also increased, right? However, with social networking, that's why I talk about big data after social networking. Social networking is what? People putting their status updates, people putting a 140-character tweet out there, right? Now that is all kind of what in technology terms we call as unstructured data. Okay. So there is a variety. So not just there is a lot of data, because technologies are down there where we can capture many different kinds of data. We can analyze a lot of those data to kind of understand what consumers want and what we can market to them and so on and so forth. But there is also this whole realm of unstructured data that is coming through social media. And how do we marry the two, right? That's what big data is about. So it's variety. And then the third is velocity. The velocity at which the data is changing. Okay? The data is not changing static. I mean, the data that you collect from many different sources, it's constantly changing. The rate at which it's getting updated, right? I'm sure you all are kind of updating your Facebook statuses pretty regularly. When we track consumer behaviors on our website, or getting other information from outside, that's changing on like not monthly or weekly basis, on a daily basis, right? So that velocity is also very important. So 3 ways is what big data is. Now again, think of this big data is kind of related to, if we never had social media, we always had data, we were always collecting data. But with social media, that has given rise to big data, because now we have to worry about not just the volume, but also the variety and the velocity. Okay? So again, the point here being is that evolution in internet is kind of leading from one technology to another. And we always talk about this new technology buzzwords, but it is interesting is when I sit back and look at all of these, is how they're all related. One's leading to another. Okay? After big data, we also talk about mobile commerce. Few years back, we used to talk about e-commerce. E-commerce was, instead of people going into a brick and mortar store, going and buying things online, right? I'm sure many of you do today. Now, we are seeing a spectrum shift. We are seeing it, the industry is seeing it, right? Where people are buying more and more through mobile devices, through their iPads or tablets or through phones. Again, this is driven by what? Driven by the fact is that because you are moving from like 2G, 3G, 4G, like high speeds, and you have a single device from where you can make phone calls, but you can also kind of do a lot of other things. You surf internet, buy things, right? People are, because as a matter of convenience, are starting to buy more and more stuff from their mobile instead of just going to their desktop or buying it online. So it's still buying online, but instead of just pure e-commerce, buying it from a website, it's now moving. The trend is slowly but surely shifting more and more towards mobile commerce. Now, why is mobile commerce different than e-commerce? Is because obviously on the mobile side, the real estate that you have on the screen is different, right? The way people like to do it, some people still like to visit the website on the phone, but most people actually would prefer downloading an app. So now corporations like ourselves have to make a lot of investment in mobile technology, right? Creating apps that will give users great experience. And now guess what? It's connected back to big data. So now, not only do you have to collect data from how customers and consumers are behaving on your website and or social media, it's also on mobile devices. What are they doing on your applications using mobile apps, right? And then the last, but obviously not the least, is Internet of Things. Again, a new term which you'll keep hearing in the next few years, I'm sure. Internet of Things is, I'm sure many of you might have seen an article or seen some sort of maybe a commercial even around how in future you may have your refrigerator also connected to internet. And then where you place your gallon of your milk, as the weight of the milk goes down and becomes empty, it automatically sends a signal to your nearest store or an online store like Amazon or others, which can then fulfill those requests, right? Fulfill in almost real time. Now, if you think about it, a few years back, everyone thought of internet as, okay, something that you plug into your computer. Then now mobile devices. Now you may have Internet of Things, meaning there are companies that are kind of coming out with things that can be network enabled, like refrigerators. In future, I mean not in future, even today you have a lot of your cars may be equipped with various facilities, such as I think GMC has OnStar, which can automatically detect if your car got into a crash, things like that. So Internet of Things, everything being connected to internet, everything being able to communicate with each other, and that's going to be interesting, right? As we move forward, more and more technologies are going to be internet enabled, and hence the word Internet of Things, because nothing is off the charts these days in terms of where and how you would use internet. Okay? What this leads to is the second point, is the circular logic of technology innovation and broadband are feeding each other. Now, one would say that a lot of these technology and emerging technology innovations, just have gone through many of these examples, you can say that they wouldn't have been as commercialized and as widely adopted as they are today if it weren't for having a pretty solid infrastructure, internet and broadband infrastructure, right? We just talked about it for the last few minutes. However, one can also argue that the reverse is also true. Had there been not more and more demand because of things such as mobile commerce and social media and big data and cloud computing, is that your broadband may not need to have more capacity, and because all of these new emerging technologies are putting significant constraint on the capacity, those capacity needs to be upped every day, right, to make it faster. People are moving from having cable TVs to now moving to things like Netflix and Roku and others, right? Now imagine your TVs being just connected to internet. I'm sure many of you have that already, and you're just streaming video. Now that's going to require a pretty heavy internet connection, right? Otherwise you will kind of see those pixels cutting out if it weren't fast enough, right? So it's a circular logic where emerging technologies are being commercialized at a much faster rate because of internet and because of broadband, but those emerging technologies are putting more and more pressure on the need for internet to be faster and having more capacity and more bandwidth. Okay? And then the last thing is, what does that mean for state and local governments, right? Even right here in Utah. This means that you will need more investment in broadband, in internet, right? Need to make it faster, because more and more companies are looking to states which have fast internet, not just for their employees, but they feel like that's an area where new technologies can be implemented first, and there will be faster adoption, because internet does not become an inhibitor, it actually becomes a supporting piece, support to adoption. And then the more demand for technology talent, right? Because as everything becomes more and more compute-based, right? We are moving from people, working in manufacturing plants to several of those working in IT, because there are not enough manufacturing jobs. Assembly lines being automated by technology, right? So there is, again, a spectrum shift towards technology more and more, and even more so in future. And as this spectrum shift occurs, what is that going to do? It's going to increase more demand for technical talent. We are already feeling it. I'm sure many of you are. I mean, at Overstock, we have tough time attracting more and more talent, because we have more ideas than we have developers and technological resources to kind of implement those ideas, right? So, and then you have heard that, well, it's both a boon and a bane, right? I mean, as Utah is one of the top 10 in terms of, is that right? Is that in the top 10, right, for the fastest internet? What that is doing is attracting more technology companies, Googles and eBays of the world. Now that means that it's a good thing, overall as a state we are growing, but on the downside, it's more competition for limited pool of resources. So now governments would have to invest in saying, okay, what do we do? And in future, they will have to invest more and more in education. Because as a short-term incentive, you may be able to incent people or incent companies to come in here, and we and corporations like us may be able to incent people by giving them better pays, better incentives, and so on and so forth. But in the long term, this technological trend of needing more and more technical talent, you would have to make some fundamental investments, such as in education, right? Educating our newer generation to be more tech savvy, to be able to take on this demand of technical talent, okay? And that's pretty much it. So investment in education to fulfill the demand. And that's it. Pretty much right on time. Thank you all. Appreciate the time. And any questions, by the way? Well, great question, and pretty much right on. For us, it's a pretty straight correlation, right? I mean, like I've mentioned, e-commerce, mobile commerce, primarily driven by internet. Faster internet speeds, meaning more and more people are, we will be able to, I mean, one great example I can give is, right, many of the people may be sometimes a little hesitant to buy online, right? One of the reasons is because they want to kind of, see it, feel it, touch it. Now, we can't do much about feeling and touching things, but seeing, we can, right? We can put some really, this technology this day allows us to put high resolution images on our website of, everything from furniture to clothes to jewelry and watches and whatnot, right? So when you have that high resolution images and you can see the details, it makes it easier for people to buy online. The downside of that is that when you put those high res images, and if the internet was not fast enough, guess how the experience is going to be? You're going to see, cut off pictures. That's not very helpful. So internet has direct impact on businesses like Overstock, which are pure play retail and pure play online retail, where we can do more with technology and put things such as high resolution images because the internet is getting there and shoppers are getting more comfortable buying online. Other questions? Okay, great. Thank you very much. Appreciate your time.